Some of the challenges facing the E&C industry include economic uncertainty, rising construction material costs, extended lead times, and ongoing skilled labor shortages. Starting with construction materials, the industry is faced with a 40-year high inflation rate, increased transportation costs, higher energy costs, and a lagging supply chain still recovering from the pandemic shutdowns. All of this has led to a 35% increase in material costs. However, 2023 does have good news. Construction material input costs are down for the first time since August 2020. This is about 1% less than this time last year. Construction spending has improved, with non-residential construction increasing again for the 10th time in the past 11 months. Most of these gains are coming from the construction projects within the manufacturing sector. Some engineering construction companies are embracing new technologies to boost productivity, to improve accuracy of cost estimates and cost controls, provide greater data transparency, and reduce human errors that can lead to expensive rework. While engineering and construction is one of the world's largest industries, it's no secret the sector can be conservative and historically slow to adopt new technology. But driven by the current industry challenges, this trend is changing. And according to a May 3rd, 2023 research article by McKinsey, the engineering construction software technology space is experiencing an explosion of investment. An estimated $50 billion has been invested in engineering software companies since 2020. Between 2020 and 22, it's 85% higher than the previous 3 years. Some of the technology being adopted include virtual design and construction, project management and cost controls, estimating simulation, Internet of Things, 3D printing, robotics, blockchain technology, and artificial intelligence. Speaking of artificial intelligence, with the recent and sudden rise of GPT deep learning, we've all seen artificial intelligence in the headlines, and in some cases, a bit sensationalized. But when you cut through the media hype, we see that engineering construction firms are currently using AI, and it's providing practical and quantifiable benefits.
My name is Jaris Tilstra, and I work in our estimating department at Interstates. I focus most of my time on estimating industrial automation projects. Here at Interstates, we are not immune to the issues David mentioned. From a supply chain perspective, some of the automation hardware has a 35-week lead time, and on the electrical construction side of the business, we have pad mount transformers out 110 weeks. Supply chain disruptions and price fluctuations make it challenging to nail down our costs for the estimate. From a people perspective, the market is tough to try to find skilled labor. We are seeing more retirements than entry into the workforce. Our recruiting team is getting creative through multiple strategies to find the team members we need. Interstates is headquartered out of Sioux Center, Iowa, with multiple regional offices and offers industrial electrical solutions tailored to meet the needs of clients nationwide and internationally. The markets we work within include CPG, data centers, energy, chemical, food and bev, value-added ag, distribution, and water wastewater. Our solutions range from consulting, electrical engineering, electrical construction, automation, control panels, modular solutions, maintenance and support, operational technology, and cybersecurity. A large part of our estimates is based upon piping and instrumentation diagrams, also known as P&IDs. P&IDs are detailed diagrams of industrial process that shows the interconnection of piping, process equipment, instrumentation, motors, pumps, control valves, heat trace, and other process equipment. A time-consuming task includes the creation of a motor and device list from P&IDs. Motor and device lists make up a large part of our estimate. Depending on the project, we're doing a lot of things with a particular device. We may need to specify, procure, install, wire, provide inputs and outputs for program, checkout, commission, and start up that device. Depending on the project, this can be thousands of items. Historically, this has been done by printing out the PIN-ID set and highlighting each motor and device and manually entering them into a spreadsheet. Now with DataSeer, we can run that same PIN-ID set through the software to create the raw motor and device lists. For example, DataSeer was able to process 100 pages and deliver a device list 3,500 rows long in approximately 20 minutes with a high degree of accuracy. This would take somebody doing it manually days to do. Motors can be shown as the piece of equipment the motor is driving, such as the bucket elevator shown on the screen, or a pump, fan, or conveyor. There's also other pieces of data associated with motors, such as the description, the horsepower, starter type, that can be a bit tricky to group together since the information does not always follow a pattern. Using DataSeer does not take the human out of the picture, though. There still needs to be a QA, QC review, and users cannot blindly trust the output. DataSeer does a raw takeoff of symbols and text as shown on the PIN-IDs, but users still need to know what the data represents, its context, and how to use it. DataSeer has also proven beneficial in extracting data from tables, creating equipment lists from electrical drawings, lighting takeoff from plan views, and even capturing text from handwritten documents. Before DataSeer actually used Bluebeam Extreme, I like to think that if a human can read the document or drawing, DataSeer is likely to read it. Some team members bought into a technology like this can be a challenge since they are so used to doing a task a certain way for years. There may be a fear of the unknown, maybe a fear of job loss. They may not trust the software. They may have data security or privacy concerns. Maybe they have a lack of knowledge or skills, or maybe they don't understand what this technology can do for them. The key to getting team members bought into a technology is to make sure they understand its benefits, they're confident in their ability to use it, and feel supported throughout the process. By taking that proactive and supportive approach, you can help ensure that the technology is adopted successfully and integrated into your team's workflow. Overall, DataSeer does the heavy lifting of the tedious takeoff efficiently, consistently, and accurately, allowing our team to focus in on more complex and creative work.
To me, what our clients are asking for is a new realm of information much sooner. They need much more accurate estimates. And to me, it is a 21st century type of a view of what's required. There has been step changes, from the slide rules over to calculators to, the different things that we use now to the computers and such. And we're stepping through some of that right now. And I think that the tools we're talking about now are part of that future vision. So if you haven't heard of Black & Veatch, we've got over 10,000 professionals and 120 offices globally. Our headquarters are in Overland Park, Kansas. We're the eighth largest employee-owned ESOP in the United States. Projects in 100 plus countries and 6 continents. 4.3 billion revenue last year. And our mission is building a world of difference through innovation and sustainable infrastructure. Just some of the things that we get into: advanced power, advisory, commercial, industrial, distributed infrastructure, environmental, federal, grid, operating assets, process, and water. We've got estimating groups in all of those different segments. Anyway, it's just one of the challenges that we face is that we want very accurate estimates as soon as possible. And if you're a member or understand what AACE defines as the requirements to achieve those accurate estimates, you'll know that typically producing a more accurate estimate creates a higher cost because there are a lot more definition items that are required. So to try to find tools that allow for that better estimate, but doesn't cost more and maybe even cost less is a very unique challenge. But that's what these tools are doing for us. One of our main steps in creating that more accurate estimate is actually material takeoffs, counting the items. If you get the counts wrong, you can't get the material pricing right or the construction labor correct because it's all based off of that scope you've got. And so our material takeoffs have got to be accurate. They've got to be timely. So I can't wait to the last minute to get the material takeoffs because then I don't have time to put the pricing and labor on it. The other thing is, and I don't know about you guys, but our company and our engineers tend to change things a lot. So, I've actually gotten an MTO one time from our electrical group that said it was final, but it was 4 different times I got it. So which one was really final? I don't know, but 4 finals makes me, have to adjust quite a few things quite often. So anyway, our tools have got to allow those last minute changes that happen because they can make a difference in a project cost, whether it proceeds forward or not. And so we've got to be able to handle that. So that's our situation. We've got to have good, accurate MTOs that we can work with. So you heard earlier in Jaris's definition of what a PNID is. And so I'll just graphically show you one here that, we pull from. And the PNIDs are such an important scope document for us because we pull so many material takeoffs. There's so many counts of different things that are priced up and helps us to organize our estimate. So the pipe itself, that's what a lot of people would think of as a PNID. Okay, give me the piping off of it. But there's a lot more to just piping. There's fittings, valves, the specs on the pipe, which define the metallurgies, the flange ratings, and so forth that's required to price that piping. The insulation requirements, electric tracing or steam tracing, and then all the instruments and the tag numbers. So what we do is we coordinate our key scope documents like the PNIDs and our estimate so that we carry the tag numbers across into our estimate. So if we need to verify later, do you have this valve in? We can go to that tag number and go find that control valve. And it's very, very clear, very easy to see. Here's the tag, here's the valve, here's the price, here's the labor to install it. And the same goes true for all of the piping and all the fittings that are associated with it. We have them in by line numbers and we have them in by pipe spec. So there's no shortcut. We can't take a shortcut on getting this definition in our estimate. That would actually deteriorate from our accuracy. We want to be able to align with our scope directly and be able to prove that we've got the right scope and the right pricing and labor and so forth in for our scope. And this is what we use. We use the PNIDs to accomplish that. But can you imagine, just sit for a moment and think about it. All right, take a spreadsheet, take an Excel spreadsheet, and now count every one of these things and put it into that spreadsheet. And oh, by the way, you've got 100 of these to do, and you've got to get it done as quickly as possible. So think about the monotony of doing that. And everyone's different. There's not a copy and paste to it because every tag's different, every line's different. And you go through that and you build that out of the PNIDs, and that becomes your material takeoff. So I've done that. I've done that for a long time. I know other estimators who've done that. And where it's satisfying to capture the information after it's done, but while you're doing it, it's not fun at all. It's very tedious, and you can very, very easily make mistakes in doing that. Doing takeoffs off those PNIDs, then people could be interpreting things differently, applying different fittings for different symbols just because there's misunderstanding. And so there's not consistency sometimes with those manual efforts. And that, again, creates errors in our estimates. And so what we found, we experimented with DataSeer to see if it could really help us. And I'm not one to just jump out there and grab the first new thing that's on the street and start using it. It's got to really work for us because our neck's on the line. When we go to our reviews and go to our clients, we have to be accurate. We're not guessing. And so what we did is we took a few of them and did manual and we did DataSeer. And what we found, well, I'll tell you in a minute or two on the next slide, I think that our results were. But we were capturing the same information as we were manually, but we were only using 1 or 2 people and for a few days to get that accomplished. For DataSeer, we saw that it was an increased accuracy because it wasn't getting tired and it was consistent. If we had defined something incorrectly in DataSeer, it was consistently picking it up that way. And we could go back and adjust that and correct that if we needed to. It was fast. We completed the P&IDs in days versus weeks doing a manual effort. And when we got updated P&IDs, it was easy to rescan those and get the new MTOs, compare and get those folded into our estimate quickly. From the results that you see here, you can see that we've accomplished the same thing that we needed to accomplish with the material takeoffs. The difference is that it took less time, less resources, and we felt like it was more consistent with what we had versus the manual efforts. Now, Jaris mentioned this earlier. This doesn't mean you get rid of the human aspect. No, because once we do this, in part of our time that we spent is going back through and quality checking. So we look at every P&ID, make sure we're picking up the valves and the fittings and everything associated with that correctly, and make sure that the MTOs are correct. So there's some time spent doing that. But in general, what we're finding is a lot faster than just doing manual efforts. Just to sum it all up, we utilize DataSeer to develop material takeoffs for high quality estimates. We find it accurate, fast, and flexible. Now, this discussion that I just presented is really around DataSeer, but there's a bigger picture to that, and that is the AI type of concept. And we do utilize other tools to help us create those early estimates that are quantity based. So providing MTOs that allow us then to produce the earlier accurate estimates that our clients are demanding these days. So DataSeer is just one of those. And anyway, the future, I think, is pretty bright for the new tools that we have out there.
Artificial intelligence, AI, combines compute and data to enable problem solving. And you get things like decision trees, neural networks, expert systems. These are some examples of AI models. And then diving one level deeper, machine learning, also known as ML, it's a subset of AI where you have models that learn from experience and make predictions and assumes that historical past is predictive of the future. It uses statistical methods to enable improvements with experience, essentially training compute machines to get better at a task without explicitly programming, right? Something. And then finally, deep learning, it's an area of ML. Essentially, it consists of deep neural network models that require large amounts of data for training due to the large number of parameters in the model that needs to be optimized. And these have been shown to be relatively powerful in terms of predictive capabilities. Another point I want to touch upon is what are the requirements, assumptions for successful application of AI, specifically ML? And at a high level, there are 3 things. First thing is data. Specifically, you need label data to ensure that there's a feedback loop on what's being learned and a mechanism for error correction. So what you predict, what the model predicts, what you actually observe is ground truth. By calculating the delta, you have an error. And this is so you actually get that improvement over time in terms of predictive performance. Now, deep neural networks require more training data since there are more model parameters to be optimized. And then naturally, the shallow, smaller ML models require less data due to the fewer number of model parameters. The second assumption is that the past is predictive of the future. So if the future is changing, slowly evolving over time, there needs to be training data, labeled of course, to support this continual learning of new patterns. And then finally, the third assumption is that making mistakes has to be okay. It has to be acceptable. So long as the prediction errors decrease over time, the model will converge to a level of predictive accuracy. The models will improve and continue to learn over time, not making the same mistakes again. In pre-construction, in the bidding phase, you have data-driven estimation tools similar to, like DataSeer. And then in feed and also during engineering design, I've also been seeing some R&D that try to optimize and predict designs based on historical, subblocks of schematics. And then during construction, there's a class of AI tools out there that try to emphasize and help with on-site worker safety to mitigate risk, to increase worker productivity, and you have robotics and sort of autonomous technologies out there for that. And then going into post-construction, you have in operations and maintenance, there's also operator training simulations, asset performance management. There's plenty of software tools and platforms that say focus on trying to make sure you have data integrity, right, in your platform, your system, validating, cleaning time series data you might have from sensors, predictive maintenance, right, and trying to do preventative maintenance and monitoring your asset data streams. And then across the spectrum of all this, there's underlying areas like supply and chain management. How do you optimize the ordering of correct parts from relevant suppliers, right? Or even project planning, controls and management. How do you ensure on time and under budget or in budget project delivery? And then specific to estimation and takeoffs that Jaris and Waymon were talking about, the ultimate goal there is really to have this digitization of diverse set of engineering documents, right? Ranging from schematics, spec sheets, vendor manuals. Essentially, the holy grail is to have this treasure trove of digitized engineering data, the single source of truth from which, once you have this, you can query and start to find patterns, correlations with successful outcomes. I'd like to conclude my session with a section on parting thoughts. This is some food for discussion and digestion. So first of all, some questions. Who's supplying and labeling all this training data that's needed for these AI tools? And who's doing this over time in case the feature is evolving as well? And then what scenarios is it acceptable, tolerable to have mistakes in the predictive model performance? Also, keep in mind, these are scenarios where there should be a repetitive, predictable task, right? Because otherwise you're predicting, different things into the future. And then furthermore, everyone can agree there's lots of data lying around in the engineering and construction space, but they're not all structured and they're not all labeled, which are kind of two requirements needed, right, for ML learning. So what do we do about these data sets? And then data security and privacy, that's yet another hot button topic that's at the forefront of everyone's mind. How do you leverage learning while still preserving security and privacy, especially when you have sensitive IP confidential engineering documents? And then the last question or last topic I'll leave everyone with is, how do you design these AI tools so that way the human and the machine work together in a collaborative, not competitive way, right? It's got to be a way that the human feels supported and at the same time feeds into all these open questions that I just listed.